Students, now the next problem what I am taking is a very important problem as per the exam point of view. This such problem we have already dealt in the range minus pi to plus pi. Now we are dealing in arbitrary range. Now this problem, they are saying that first we have to draw for the graph of the function f of x is equals to pi x in the range 0 to 1, pi into 2 minus x in the range 1 to 2. And also show that the Fourier expansion of the function is. We have to show our Fourier series as in this manner. Now to start we need to draw for the graph. So to draw for the graph I have already explained how to draw by in the function that is mod x. Here already the function has been divided into 2. There is no problem in splitting out the function as we had splitted out in mod x. Now here take f of x as pi x which has been given already in a closed interval 0, 1 and also f of x is equals to pi into 2 minus x in the range 1 to 2. Here as we know that y is equals to f of x, already we have been studying in the previous of our classes. We know that y is equals to f of x and we know that f of x is equals to pi x. So indirectly it means y is equals to pi x. And y equals to pi x means what? We have already learned there is a equation of the straight line. We have studied here y is equals to mx, right? Y is equals to mx means what? It is the equation of the straight line passing through the origin, subtending an angle of 45 degrees with the x-axis. Already I have explained in my previous problems. Okay, that is video. So this was representing y is equals to mx. So likewise, now I am having y is equals to pi x, means my slope is now here pi. So need not to worry, the same figure will be there, only the slope will be what? Pi x. So this is your line which is representing a straight line. So when I am having a function y is equals to pi x means it is in the form of y is equals to mx, which is a line passing through the origin. Now next function defined is f of x equals to pi into 2 minus x. We are having a equation. There are a number of forms of straight lines as we have already gone in the previous. We are having x by a plus y by b is equals to 1. This is also an equation of the straight line which is having, we can say it as a slope intercept form, or we can say having a x-intercept as a and y-intercept as b. So up till now we have studied for such a straight line we used to draw or plot the points in the form of a comma 0 because x-intercept is a. So this will become a comma 0 and y-intercept is 0 comma b, which I will join these 2 points. So this is what the equation of the straight line, how to draw. Now here in this problem we are having y is equals to pi into 2 minus x. When such case arises, try to convert this in this standard form. So to convert it into standard form, try to multiply pi inside. So this will become 2 pi minus x pi. Take x and y terms one side. So this will become x pi plus y. This minus x pi, when it comes this side it will become plus x pi. And this plus y will remain as it is, equals to 2 pi. In our standard form it is equated to 1. So I will try to equate this as 1. So I will divide the whole equation by 2 pi. So x pi upon 2 pi plus y upon 2 pi is equals to 2 pi upon 2 pi. Such that 1 pi will get cancelled. Here I am remained with x by 2 plus y by 2 pi is equals to 1. Have I made it in the standard form? Yes. Once I make it in the standard form, now as I told you, x-intercept is a and y-intercept is b. Likewise, x-intercept is 2 and y-intercept is 2 pi. So the point when it is a x-intercept, it will become 2 comma 0 and for the y-intercept it will become 0 comma 2 pi. So when I am plotting the point as in this main figure, I will take the points as here x point is from 0, this is 2 comma 0, means I will take on the x axis 1 comma 2 comma 3 And on the y-axis, I will take it as pi, 2 pi, 3 pi and so on, because your y coordinate is in terms of pi. So I will take here in the graph as 1, 2 and this is 3 and so on. Similarly, here I will take pi, this has 2 pi, this has 3 pi and so on. Now when I plot the point, this is 2, 0 and this is 0, 2 pi. So when I am joining these points, this will become a sawtooth wave. So that is a triangle wave. So this is when I drop a perpendicular, this point is 1, pi. This is the point 1, pi. And when we are talking for periodic functions, means this graph will get repeated after the interval of 1. This will become 4. So this is going to be like this. So this way we are going for the graph. So once we finish drawing for the graph, we are going to go for the Fourier series. This is only what I had explained here. Now to go for the Fourier series, my range is how much? My range given is 0 to 2. So it is a closed interval. We need to compute for L value. So take 2L is equals to upper limit minus the lower limit. So L value is 1. Now we need to check for even or odd function. So since the function has been divided into 2, take phi of x as pi x and psi of x as pi into 2 minus x. As our range is from 0 to, we are going to replace x by 2L minus x. So as we are having L value, so this will become 2 into 1 minus x. Means x has been replaced by what? 2 minus x. So when I substitute here in phi of x, 2 minus x, I am getting it as same as psi of x. And if the function comes same, means what? It is even. And if it is even, Bn is 0. Now we are going to compute for a0 and an only. So a0 formula is 2 by L integral 0 to L f of x dx. So L value is 1, 0 to 1 f of x dx. Now what is f of x now? As the function is divided into two intervals. One is 0 to 1 and another one is 1 to 2. So which function you are going to consider? 0 to 1 interval, pi x will be considered. So this is pi x. Pi is acting as a constant, it will come out. Integration of x is x square by 2. Limits ranging from 0 to 1. 2 will get cancelled. Upper limit is 1. 1 square is 1. 1 into pi is pi. And lower limit is 0. So a0 is pi. Now we are going to compute for an. An formula is 2 by L integral 0 to L f of x cos n pi x upon L dx. So where all L is there, substitute 1. Now since my range is 0 to 1, so f of x is pi x. Pi is acting as a constant, and since it is into, here into it is, so bring pi outside. So it will become 2 pi. I am remained with the product of x into cos n pi x, which I will be applying Bernoulli's rule. Simplifying the signs, substituting upper limit minus the lower limit, I am getting an as 2 pi upon n square pi square into minus 1 raised to n minus 1. Pi will get cancelled. Once I get pi cancel, I am remained with 2 upon n square pi square into minus 1 raised to n minus 1. This is an. Hence my Fourier series expansion will become a0 by 2 plus summation n equals to 1 to infinity an cos n pi x upon L. So where all L is there, substitute. a0 you substitute, an you substitute, you will get your Fourier series in this manner. This is not your final answer because I need to express the Fourier series in the form of pi by 2 minus 4 by pi cos pi x upon 1 square plus cos 3 pi x upon 3 square and so on. So since it is a, now here pi by 2 plus summation, here bracket is there, and if I take n value as odd, its bracket value is coming minus 2. If n value is even, its bracket value will become 0. I will restrict this summation as 1, 3, 5 and so on. So this minus 2 and 2 will become minus 4, which will come outside. It will become minus 4. This pi will come outside the summation, so it will become 4 by pi. summation 1 upon n square cos n pi x. Now go on splitting out the summation. So n equals to 1, 3, 5 and so on. You will get your required form of Fourier series, which is a very important problem as per the exam point of view. Thank you.